This video is an introduction to atomic structure at National 4 and National 5 level. What you need to know about the atom is pretty similar for both courses. So this is just a little introduction. We're going to remind ourselves of the three subatomic particles, the definition of atomic number, and answer this question: why are atoms electrically neutral? If you're feeling pretty confident with all of these things, then you might not need to watch this video, but if you're a little bit unsure, keep watching. Make sure that you've got a pen or a pencil and some scrap paper to write on, because I'd like you to think about your own ideas before you then listen to me explain the answers to some questions that I'm going to ask in the video. It's really important that you take the time to do this, to try and remember what you've learned about this topic before. The whole process of remembering our prior knowledge really helps us to learn better in the long run, so please do take the time to do that. First question then. What is an atom? You don't need to write this down. You can if you want, but just take a little minute to think about that. Okay, so what a little simple picture here. Hopefully one of the first things that comes into your head when you think about what is an atom is you might think an atom is a tiny particle. You also might think, based on your previous knowledge of science, that an atom is a tiny particle that makes up everything around us. So in chemistry, we have a theory called atomic theory, particle theory, and that theory tells us that everything is made up of atoms. We use this theory to explain why the world around us is the way it is. So atoms are tiny particles, they make up everything. In chemistry, we tend to represent atoms, if we're thinking about a kind of general particle model, we represent atoms with just a little circle. And we tend to use different colours for different types of atoms in this type of model. One important thing to remember from your previous studies of science is that elements, substances which are elements, are made of only one type of atom. So remember, all of the elements can be found on the periodic table, things like gold, silver, carbon, oxygen, pure substances which are made of only one type of atom. So that's atoms in general. Let's look at atoms in a little bit more detail. Okay, question number 2 for you then, our current model of the atom. What I'd like you to do is try and draw a little sketch which you think represents our current model of the atom. If you want to pick a particular one, I would do a helium atom. In your sketch, try and do as much detail as possible. Especially, I want you to think about what the three subatomic particles are, their names, and where in this picture of the atom they might be found. So pause the video now and have a go at sketching an atom. Okay, so mine's quite detailed. I've had a little bit of time to practice, but hopefully yours looks something like mine. At the very least, I'm hoping that you've got a little bit in the middle and then another bit around about. Hopefully you remember that atoms actually are mostly empty space. This diagram's not to scale. My particles here, what we call subatomic particles, are quite big, but atoms are actually mostly empty space, and the particles inside them, what we call the subatomic particles, are really tiny. Hopefully you remember that at the middle of an atom we have a portion called the nucleus. So this is the centre of the atom. It's where most of the mass of the atom is located. And then around about the nucleus we have what we call electron shells, or energy levels. So that's what's represented by this circle here in pink. And then we've got our three subatomic particles. So we've got protons. That particle is in the nucleus, and I've put a little plus sign on mine to represent the fact that protons have a positive charge. Second subatomic particle is the neutron. Neutrons are also found in the nucleus, in the centre of the atom. And then the third subatomic particle is the electron. So electrons are found, surprise, surprise, in the electron shells. Another word for electron shells is energy levels. So electrons, we say that electrons orbit the nucleus. You can think of it a little bit like the planets orbiting the sun. Electrons orbit the nucleus of the atom, and they do so in fixed electron shells, or energy levels. I've only shown one energy level in this diagram. Okay, so Next part, definition, atomic number. I'm going to start off a sentence for you and see if you can remember the rest of it. So, the atomic number is the number of. Pause the video and see if you can remember what that answer is. It might help to have a little think about this picture of the atom. Okay, so you might remember it, you might not have remembered, don't worry. The atomic number is the number of protons in the nucleus of an atom. So if you remember, I said that I'd like you to draw a helium atom if you were going to choose an atom to draw. In my helium atom, I have drawn 2 protons in the nucleus. Now I've just said here that the atomic number is the number of protons in the nucleus, so that means that the atomic number of helium must be 2. Hopefully you'll remember that the elements in the periodic table, so here's a periodic table now, the elements in the periodic table are arranged in order of atomic number. So hydrogen has atomic number 1, helium has atomic number 2, oh, there's helium here, lithium 3, beryllium 4, boron 5, and it goes on like that. So these numbers that the elements are arranged in order of are the atomic number, and like we just learned, they correspond to the number of protons in the nucleus of an atom. So my helium atom, the atomic number was 2, it has 2 protons. Boron, for example, atomic number 5. Boron atoms therefore must have 5 protons in the nucleus. Okay, so that's the atomic number. Next question, why are atoms neutral? So I'm going to again start the sentence off for you. Atoms are neutral because they contain the same number of, well, I've given you quite a clue here, the same number of positive protons and something. So looking at our model of the atom, to be fair, in this one we've got the same number of protons and neutrons, but the neutrons don't have any effect on the electrical charge of the atom. The neutrons are neutral. So in our atom we've got the same number of positive protons and this particle here, these are the negative electrons. So atoms are neutral because they contain the same number of positive protons and negative electrons, and the charges of these two particles cancel out. So in chemistry, whenever we've got the same number of positive and negative charges in a space, so we can think of the atom as one space, the positives and negatives cancel each other out. So 2 positives and 2 negatives add up to an overall charge of 0. That's why our helium atom is neutral, and all of your other atoms of elements in the periodic table will have the same number of protons, same number of positive protons and negative electrons. The charges will cancel out, so all atoms are electrically neutral.